Hello guys, welcome back to the channel. Okay, today we're gonna look at very interesting graph problem. This problem has been labeled as hard. This is from LeetCode 827, making a large island. Let's see what we are given. So we are given an n by n binary matrix grid, and we are allowed to change at most 1, 0 to be 1. Return the size of the largest island in the grid after applying this operation. An island is for directionally connected group of ones. So there are 3 examples. One example is 1, 0 and 0, 1, and the output is 3. So we will look at this in the one node. In example 2, 1, 1 and 1, 0 and 1, 1, 1. We can see the size is 4, right? So we'll look at in the one node. And the grid lengths, basically rows and columns, they are equal, so they're going to be the grid lengths. And the n can range, basically the row and column can range from 1 to 500. And each grid cell value of the grid I and j, they can be either 0 or 1. And this problem seems like it's a graph problem, and so many companies ask it, including Meta, ask it 25 times in the last 3 months. Airbnb, Amazon, Google, DoorDash, Microsoft, Uber, Adobe, Oracle, and Snap, right? So this is a very interesting problem. So we are given and the islands and the water. In that case, we need to return the largest island after converting 1, 0 to be 1. So let's look at one node. Okay, so initially we are given this. Let's imagine we are given this grid 1, right? So 1, 0 and 1 and 1, and this is the initial grid. So what we are being asked, if you convert one of the right now, how many islands are there initially, right? There is one island and the second island and third island, right? So the area of the first island, there is only 1, right? If you just sum up all of the ones, area will be just 1, right? And for this one, area will be 2, and for this one, area will be 2, right? Now we are being asked that we can change. There are how many zeros? 1, 2, 3, 4 zeros, right? We can change only 1 0 to 1. So this 0, if we change to 1, right? Then this island, right? Let's say island number 1. I mean, let's not just do this. So this island with the area of 1 will be connected to this island with area 2. Basically, we are being asked to return the maximum area, right? The area of the largest island. If we convert this one to be 1, and all of this island will be connected, and 1, another 1, and 2, 1, it will be, area will be 4, right? If we convert this one to be 0, right? To be 1. If we convert this one, for example, to be 1, right? In that case, it's 2 here, and there is 1, right? And with this, total will be 4, right? We have how many zeros left? Right? 2 more, right? If we convert this one to be 1, in that case, right? This area is 2, right? Then this island will be connected to this island, right? Let me just delete this. Okay. So if we convert this one to be 1, right? and this area, this island, will be connected to this island, right? And the total area of this large island will be 5, right? Then if we have only this one left, if we convert this one to be to 1, then area up is 2 and it will be connected this way, so it's again 5. So basically we can return 5, right? So there may be some edge cases where all of the island, they can be all zeros or they can be all ones, right? If they can be all zeros, then we can convert only 1, right? In that case, we need to return, right? Return only 1, right? Because we can convert only 1 0 to 1. And if it's all 1, this is done. If it's all 1, then we cannot, there is no 0, right? We cannot convert any 0 to 1. So maximum area of this is basically 6, right? So we need to return 6. So these are the edge cases. So now we need to be looking at the case where it's not all 0 or it's not all 1, right? It's a mixture of ones and zeros. So what is the how we can solve this problem? So we have a number of zeros and number of ones. So one way of solving this problem is basically we need to mark each island by the number, right? So let's say here 0, right here 0 is island, and 1 is basically, no, 0 is not island. 0 is not island. 0 is water. And 1 is island, right? 1 is island. In that case, all of the island we need to mark, right? We need to mark if, let's say, we're going to start iterating from the beginning of the grid, and we found one island. We check its neighbors, top and bottom, right? And also left and right. And the top will be outside and the left will be outside the grid boundary. And we can check only this and this. If it's 1, we basically collect the area, compute the area of this island, right? What's the area of this island is 1, right? But we cannot just leave it as 1. We need to mark this one as let's say we need to label this each island, right? Each island we will need to label. How are we going to label? So 0 and 1, they're taken. So we can start labeling with number 2, right? The first island we encounter, we say label, right? Label, we need to start, okay, 2. We can say 2, right? So first island, we encountered first island. What's the label? Label is 2. We will basically replace the cell value from 1 to 2. Okay? So what we do? Then we keep the dictionary or the hash table where we can put the label as a key, right? This label, and area is here. Area is 1, right? Area as the key, right? Let's say the label, and this is the size. I can say size, right? Size is 1. For the first island we encountered, since 0 and 1 are taken, so we can use label. We can start labeling from 2, right? So 2, we just replace this cell value to the label. And the area, after we compute, either we can use the DFS or BFS to label this, and a size will be, we just keep this dictionary, right? Then we to the next one, this is 0, so this is water, we don't do nothing in here. Then we, after we encounter this will be second island, so we increment the label to 1, which will be 3, right? This is a new island, so we need to give a new label, right? So, and we compute the area of or the size of this island. The size of this island, first of all, we need to replace this cell values with the label. Label, since we incremented to 3, we need to replace this to 3 and all of its neighboring cells, right? It's neighboring 1 cells like this. Also, we need to replace this to 3, right? Then we say, okay, label with 3, what's the area? Area on the size is 2, right? So then 2. Okay, good. So now we start coming from here and here, all 0. Then this is already taken into account. This is because the size is 3, right? We check if it's 1 only, right? Then we come here. Now after we are done with this island, then we need to increment this one to 4, right? It's a new island, right? We need to give a new label. So we basically, this area, we compute this area of this island by going all 4 directions. Then we get the size of this island, and this is the label, right? We say the label is a key, and the size is the value. This is also 2. Okay, so now we got this will be basically island 4 and island 4 with the label, right? It's not really 4, but we start from 2. That's why island 1, island 3, island 2, island 3, island 4, they all have the size, right? They all have the size. So after we get the sizes, now this is the first iteration in the grid, right? And the second iteration, so this one is basically in the first one, the step 1, the label islands and calculate the sizes. And we can use either BFS or we can use the DFS to traverse the grid and label each island with a unique identifier. And where we started the label from label 2, because island numbers 0 and 1, they are already taken. And we can store the size of each island in a dictionary for quick lookup, right? That's what we did. So this will be the label of the islands, and the values are the sizes of those islands. Now, this steps are done. And the next step 2, now we can start changing all of the zeros, right? From all of the zeros 1 by 1, right? This 0, let's say, after we change this 0 to 1, right? If we change this 0 to 1, then what we're going to do? We check its 4 directions. We check this direction, we check this direction, which is all 4 directions. Up is gone, outside the boundary of the grid. Then we check the values. What we do, we keep the neighbor as a set, right? Let me just start with a set, let's say with the set. And after we convert this one to 1, right, the size is already 1 because this is 1, right? Let's start from 0. Okay, let's start from 0. Size from 0. Now what we do, after we convert this 0 to 1, we check its all neighbors. Let's say the left neighbor is 2. We keep this in a set. And we go to the right and we check the label. Label is 3. We also kept this in a set, right? So we collect all of the neighbors of 0 after we convert that to 1, right? To 1, right? Then we found this, right? We found 2 and 3. These are the labels of the islands of the neighboring islands to 0 after we convert this one to basically 1, right? Then what we do, we iterate this one, right? Now we need to iterate this set and check for each element, because each element is a label of the island, right? Then we check in this is a dictionary, right? This is a size dictionary. From the size dictionary, we check for this label. We get the value, right? We get the value. What's the value? Initially it was size 0. Let's say it was 0. Now we need to 0, right? We need to add, after we check this 2, what's the value of K2 from the size dictionary, right? We see it's 1, right? The size of this island is 1. Then we go to another island, which is 3, right? What's the 3 value of 3, right? The K3, it's 2. So it is returning 3, right? Is that really 3, right? We are missing 1, right? Why? Because after we convert this 0 to 1, this is also 1. It's adding 1, right? So now this is 3 to after we add 2 neighboring islands, they are giving 3, but we need to add 1 more because the 0 is becoming like 1, right? Then we need to return 4. So what we do, basically we keep this one as a size. Right now, after we convert the first 0, we got the size 4, right? Now is a size, we update size to be 4, right? Now then we go to another 0. We just traverse until we find another 0. Then what we do the same thing, right? We convert this one to 1 and we check its neighbor. It's 2 and this neighbor is 4. What's the size? Size of this is 2, right? Because we just look up in this dictionary, size dictionary. And then this here it's 1, 2 plus 1 and plus 1, it will be 4. 4, it's equal to this, so we do not update, right? Then we come here. We convert this one to be 1, right? After we convert this to be 1, the size of this island will be connected like this, right? Like this. So after we convert this one to 1, the size of this island is 2, size of this island is 2. So 2 plus 2 plus 1 more, like 0 after we convert, it will be 1. So 1, it will be 5, right? Basically then it's larger than this 4, so we update this to be 5, right? Then we just keep iterating until we just come here. Then it will be, we convert this one to 1 and it will connect this island to this island again in the corner. So it will be again 2 plus 2 plus 1, it will be 5. So we do not update. So at the end, we need to return this, right? So we basically in the step 2, we evaluate changing zeros to ones, right? So what we do, for each 0 in the grid, we need to calculate the potential island size if it will change it to 1. That's what we did. That's why we just, each 0 we are converting, right? So then combine the sizes of the neighboring islands, if any, and keep track of the maximum size found, right? That's what we did, right? This is basically a 2-step algorithm. So we are iterating this grid twice. In the first iteration, it's a time complexity. There will be 2 iterations, right? Time complexity will be O of n squared, right? And the second iteration, again, O of n squared, right? Why? Because in the first iteration, we are computing all the sizes of the islands. And the second iteration, we are converting like zeros one by one to one, right? We're converting each 0 to 1, and we're iterating that grid again, right? Basically, it will be again like O of n square, right? And space complexity will be again O of n square, right? So this is basically the entire algorithm. So for this, we can also, for the testing purposes, we can just go through this larger grid. So let's say for all of these will be, no, this will be 1. So this will be 0, 0, 0, 0, right? And all of the ones, this is one island, right? This is one island. No, yeah, this is one island because they all are connected. So we can say this is 2, right? We can change all of them to 2, 2, 2, 2, 0, 2, right? And 2, 2. And this will be 0, 0, 0, 0, 0, 0. No, not the 0. This is not 0. And this will be now third island, right? 3, 3, 3, 0, 3, 3, 3, 3, right? So we can see the maximum island. We can follow the same like algorithm here. So maximum island, we find the area of the first grid is basically 7, and the area of the second grid is also 7, right? So we can follow the same steps. And what we observe after we after we convert this will not be maximum, this will not be maximum, this will be maximum, right? After we convert this 0 to 1, this island will be connected to this island, right? Basically 7, the largest area of the island, 7 plus 7, right? Then this 1 will be 1, and plus 1, it will be 15, right? And also we can get the maximum by converting this one to 1. So total will be 15, either this one, right? This also connects this island to this island. That also gives 15, right? So this is basically, that is the case. And we already considered this, the all zeros and all ones. Or if it's all 0, we need to return 1, right? If it's all 1, then this is just all one island, and we need to return the maximum size, or we can just return the size of the island, right? So that is for this problem, and we can go back to the code to explain. Let's see the code. Okay, so we can do, as I said, we can do either BFS or DFS. So here in the first step, we are computing all of the rows and columns, and for traversal, checking all of the neighbors, we need to get all the directions, and we need to start the label from 2 because 0 and 1, they are taken already. Then we initialize the island size dictionary to store the size of the islands, where the label is going to be the key, and the size or the area of each individual island can be the value, right? Then in the step 1, as I said, in the step 1, we are gonna iterate in the grid. If we encounter the 1, then we need to do DFS or BFS to get the size of the island, right? Then we need to return the size. From there, the island size dictionary, this label is going to be the key, and island size is going to be the value, right? After we are done with one island, then we need to increment the label, right? So if there is no island size, which means that if all of the island it's 0, then in that case we need to return 1, because we can convert only, we can flip only 1 0 to 1, right? So we need to return 1. And then here we need to, after we are done, this is going to return the island size dictionary. So all we need to do, basically return the maximum size of the islands, right? So then now here we can just we can just look at the DFS, or I also have a BFS function. So we can just look at the BFS function here. We basically add the row and column to the queue, and we update the label to like any label of the island, right? Then island size initially we initialize to be 0, right? Then while queue is not empty, we pop that queue and increment the island size by 1, because our grid is binary, so we don't have to worry about the values of the cell. They are either 1 or 0. In our case, it's 1. So then now we need to check 4 directions, because we have this direction list, right? Then now we need to increment, not add dr and dc in 4 direction, go up, down, left, and right. They need to be within the boundary of the grid, and it has to be 1, because we can only go if it's an island, right? Now then we need to update the label of the island, right? Because we don't want to come back to that island again. Then we need to append that cell to the queue, and we need to just process until queue is empty, and we need to return the island size, right? So after we are done with the island size, and step 2, we're gonna start iterating again from row and range rows and column and range columns. If the grid row and column is 0, now we need to collect the neighbors, right? The labels of the neighboring cells. So now we here again we need to go to in the 4 directions, right? For each 0 we need to check all 4 neighbors, right? That's what we're doing here. Now we can compute the new row and new column. They need to be within the range or within the boundaries of the grid, and it has to be larger, greater, or equal to 2. It cannot be 0, it cannot be 1. It can be 2 or larger than 2, because that's where we started, right? The smallest island label is 2, right? So in that case, we add that cell, the value, or the label to the set. Because why we are keeping set? Because we don't want duplicate islands, and if we can also keep the list, but it can keep the duplicate islands, right? So then we just add here to the neighbor set. Then we just initially we set current size 1, because that 0 is we are changing to 1, right? So then now we're gonna iterate through this neighbor set, because neighbor, like if there are 2 neighbors, 2 and 3, so we need to go first 2 and check the area, right, from the dictionary, and 3 check the area, everything in the set, right? So then current size is going to be island size dictionary. That's what we are returning here, right? Basically, we are computing this island size dictionary. So we're going to get the neighbor level, neighbor label. Then we, from that, by looking at, we can look up in the dictionary what's the area of that specific neighbor label, right? Then we say the maximum size is going to be maximum of current size and maximum size. And finally, we return. Yeah. So basically, to recap, so this is it. And I also have this DFS. Instead of the queue, we can use the stack and follow the same thing and return the island size. So this perfectly works. So basically, there are 2 steps. In the first step, we are iterating and computing, labeling all of the islands, and keeping the dictionary where the island label is the key and the area is value, right? Then in the second iteration, we are converting each 0 to 1, 1 by 1, iterating through the array one more time. Then we are returning the maximum size by adding the neighboring, the size of the neighboring islands, right? And we return the maximum size. So we can submit this. So you can see this is it's doing really great. It's above 8%, right? So I think this is really interesting problem. This many things can be learned from this by really understanding and tackling this problem, right? Yeah, I hope this explanation is clear, and if you like this explanation and the problem with one node and the code walkthrough, and please like and subscribe and share this content with anyone that you think might be helpful. Okay, thank you. I'll see you in the next video. Bye.